Okay, everyone, we're going to start again on chapter 8. I believe in your homework, this might be 8.1 through 8.2. We'll see how it goes, how much we can finish. But in your notes, I'm pretty sure this is 8.2 and let's see here. In your notes, this is actually moving into 8.3. So I wanted to send out a video to kind of finish up most of chapter 8. For this one, I'm going to actually show you guys how you can use the calculator. If you were in the meeting we did today, we did this problem without the calculator, just doing it by hand. So now I want to show you guys that you can use the calculator for your test statistic. So I'm going to go into step 2. So we know that our claim right here, I want you guys to notice something. It says the proportion of religious surfers who belong to a religious community is different from the general population. So that's the claim. So in this problem, the claim is stating that the proportion reported is 69%. So that's kind of what they're saying is the general accepted value. And we want to see, based on our sample, if it's different for religious surfers, okay? Being part of a religious community based on our sample. So what we're going to do is we're going to write out our claim. So P cannot be 0.69 or is not equal to 0.69. And then the opposite of that would be 0.69. So this is equals and not equals, because it doesn't tell us if it's greater than 0.69 or less than 0.69. It just says that it's different than the 69% that is presented. So then we're going to try to now build the null. And remember, like in the previous videos, it's very easy to identify the null. It's always the claim that has the equal sign. So in this case, the null is P equals 0.69. And hold on real quick. Let me just clean something up. Let me do this. Okay. We may not have enough room, but we'll give it a shot. So then the alternate hypothesis would be P is not equal to 0.69. Remember, the alternate can never have an equal sign. So it'll either be less than, it'll be greater than, or it'll be not equal to. Those are your only 3 choices for the alternate. And the null will always be equal for our class. Okay, so if you're writing it differently, it's not right. Okay. So now we have to do part 3. Okay, and again, I'm showing you guys step by step like this because this is an intro class. If you guys go on to be statisticians, you're going to do it much quicker than this. You're going to do it your own way. But this is just kind of our, will be the adopted way we do it for our class. Okay. So let's do part 3. We know that alpha, they say right here, is 0.01. Okay. And we know that this is a 2-tail test. We know this is a 2-tail test. And the way we know that is, remember, we look to the alternate hypothesis, and the alternate hypothesis tells us 2-tail, okay, because it's a not equal to. If it was a less than, then it would be a left tail test. If it was a greater than, then it would be a right tail test. But both of those are 1-tail. Because this is 2-tail, we're going to use a because it's a not equal to, we're going to use a 2-tail test, okay? So let's do part 4 now. So part 4 is the test statistic. Now, normally we would have to go through and do P hat minus P divided by P times Q divided by the square root of N, right? All like that. But what we're going to do instead is we're going to try to use our calculator now, okay? So what I'm going to do is I'm going to go in my calculator and I'm going to do, it says it right here, if you look in your notes, right here, it says if you want to use your calculator, you can do stat test 1 prop z test, okay? So this will help for taking the test online as well if you're taking the online exam. Let's see here. So we're going to do what they said, 1 prop z test. So 1 prop z test, okay? And we're going to type in what it tells us to use, okay? So let's see what it tells us to use. Let's go to stat test, And I'm going to go down on my calculator. It's the 5th test. It says number 5, 1 prop Z test. I'm going to hit enter. And now it says P sub 0, P naught. Well, our P naught in this case is 0.69, meaning our null hypothesis. That's going to be this guy right here. Oops, sorry. That's going to be this guy right here, 0.69. So I use that. Okay. Then it says, what's my X? Well, we know there in the sample, there was 378 people out of 512. That's the N. And then they want to know what type is it? Is it a not equal to, a left tail, or a right tail? So we're going to say it is a not equal to. Okay. So you just enter that in your calculator. Go down to calculate. And it will tell us Z is equal to 2.362, okay, if I round off. But it tells us something else. It also tells us the p-value. So I'm going to go over here and I'm going to do step 5. Step 5 says that we know the p-value. Well, if Z is right here, it tells us that this is a two-tailed test. So we also have to go over here. And remember, this is supposed to be symmetric. My drawing's just really bad, okay? But this is supposed to be symmetric. So it tells us that Z is 2.362. And by the way, I'm doing the p-value method for this. Maybe I should write that p-value method. I'll write that up here. Okay. So this is negative 2.362. Now the good thing is it actually tells us that if you add that area plus that area, it tells us the p-value would equal 0.018. Okay, about. Okay, so those of you that were in one of my stats meetings, I actually forgot to do, in one of the classes I remembered, but for some reason I forgot to double the p-value. So in this problem, I believe I did the very end incorrect. So I'm going to remedy that right now. So those of you that have it slightly different in your notes that showed up to the meeting, please fix this. Because remember, if there's a certain amount of p-value, you technically have to double it because whatever's over here is over here. So if I take 0.018 and I divide it by 2, that actually means, maybe I should write it like this. It actually means that we have 0.009 here and 0.009 here. So when we add those up, we get a p-value of 0.018, okay? So whenever you have a two-tailed test, whatever the p-value is that you find by hand, you have to double it, okay? Now the thing is, if you're using the calculator, so on my calculator, it already told me the p-value was 0.018. The calculator already knows it was a two-tailed test, so it already doubled the p-value. So it actually handed it to you, okay? So we now know that our p-value is 0.18, and then we know in step 6, we're supposed to say whether we reject the null or fail to reject the null. So our p-value is, here we go. If the p-value is less than or equal to alpha, reject the null, okay? However, if it's greater than, then you fail to reject the null. So in our case, our p-value is 0.018, and that is actually greater than our alpha, which is 0.01. So we fail to reject the null. Okay, I'm writing kind of quick because there's not a lot of room here, or I'm writing in a very small fashion. So let's just kind of finish this problem off. So step 7. Sorry, you guys, I don't want to bleed it over into there, even though I probably should. Yeah, let's do that. I was trying to have it nice and clean, but it just doesn't look like it's going to work. Okay, so since our p-value is greater than alpha, we fail to reject the null hypothesis, okay? So now we do step 7, and step 7 says there is insufficient evidence, evidence to support either. So it is possible that the null is true. It is possible that the null is false. We just don't have enough evidence to state that. So it's kind of like I was telling students in one of my other classes, kind of like when you watch those TV shows about court on TV, on the, Netflix or whatever, and there's some kind of lawyer and the jury comes out and the jury says, we find the defendant guilty or not guilty. Okay. Well, here's the thing. They don't actually say we find the defendant innocent. A not guilty verdict just means they didn't have enough evidence to find them guilty. Okay. So it's kind of like the null. The null is either false or you don't have enough evidence to disprove the null. So you don't say you accept it, but you also don't say that you will reject it. Okay. So then you could go on further doing, other types of stuff to find out that maybe the null was true or maybe the null was false. But for our class, we have two choices. We either reject the null or we fail to reject the null. That's it. Okay. There's no other option for us. Okay. We either reject the null or fail to reject the null. If we reject the null, then we're allowed to accept the alternate hypothesis. If we fail to reject the null, then we can't really say much about either claim, either hypothesis. Okay. We just don't have enough evidence to disprove the null. All right. Okay. So now hopefully you guys got the hang of it a little bit. Let's take a look at this next problem. Okay. So again, I'm going to try to use the p-value method. The reason I'm using the p-value method a lot is because you will not be taking the exam with me in class because of the COVID-19. So we will be using the online exam again for this next exam on chapter 8, 9, and 10. And almost, I don't want to say every single one, but most of the problems that are in this book are p-value problems. So using the calculator will actually be to your benefit, okay? Because if you have technology, the p-value method is very fast. As you could see, I found the p-value. You guys all know that this value I got here was from the calculator, and the calculator also told me this value on the same screen, okay? So using the p-value method combined with your graphing calculator is pretty nice for chapter 8, and we're going to use it a lot in chapter 9 as well. I normally don't use it this much for chapter 8. I make you guys do it by hand. But because, again, you're going to be doing it online, there's really not much I can do to stop you from using your calculator. So I figure I might as well show you how to do it right. Okay. So let's go step 1, and then we're going to go step 2, and then we're going to go step 3. Okay. We'll do this real quick. Okay. So it says sports cars owners in a town complain that the state vehicle inspection station judges their cars differently from the family style cars. Previous records indicate that 30% of all passenger cars fail the inspection the first time through. In a random sample of 150 sports cars, 50 failed the inspection. 50 failed the inspection on the first time through. Is there sufficient evidence to indicate that the proportion of first failures for sports cars is higher than the proportion for all passenger cars? Okay, so they're trying to say that previous records indicate 30% of all passenger cars fail the inspection, okay? They're trying to say if sports cars are different, right? If they're held to a different standard. And they want to say that it's higher than the proportion of all passenger cars. So what I'm going to do is, and again, is this a proportion? Is this a proportion? Or you have to ask yourself, are we dealing with mu? Are we dealing with p? Or are we dealing with standard deviation? So hopefully you guys, whenever they're talking about 50 out of 150, and they're talking usually about percents. I can't promise you all the time. If they worded something strangely, I bet they could, try to trick you on some of these. But in general, when you're working with percentages, unless it's the average percent, but in general, when you're working with percentages, you should probably lean towards population proportion. And then on top of that, if they tell you how many are in the sample and then how many out of the sample did this, that's almost a guarantee it's a population proportion problem. So I'm going to be working with my claim and my opposite claim. Okay. So we're doing P and P. We already know because we're doing population proportion. And we're going to say that it is, let's see here, the claim is that it is greater than 30% or 0.30. And remember, the opposite has to account for everything else. So if this is greater than 30%, well, we now have to count for 30% or below. So we're going to use less than or equal 30%. Okay, that's a pretty big circle. Less than or equal 30%. So now let's look at the null. Let's look at the alternate hypothesis. Now the null is always the one with the equal sign. So in this case, I see that that has the equal sign. So that is going to be my null. This is my null. Okay. So I'm going to come over here. I'm going to say P equals 0.30. And I'm going to say P is greater than 0.30 for my alternate. Okay. Now here's the thing. I have some students always ask me, well, what happened to the less than? Well, it was less than or equal to. So that means it was the one with the equal sign. That means that the null is that claim, okay? So we take, and remember, the null will always be equal, and the alternate will strictly be a less than, a greater than, or a not equal. It will not be allowed to have an equal sign in it. So the alternate does not have an equal sign, and the null always has the equal sign. The H sub 0 always has the equal sign. So now we know our alpha is what, and in general, alpha will be given. In this case, it was 0.10, right down there, okay? And what type of tail test? Once again, think back to the video and what we talked about earlier. This tells me right here that it is going to be a right tail, or you could say right direction test. So when we're doing our hypothesis, we know that the value is going to be on the right-hand side, okay? Because it's greater than. So now let's do step 4. Oops. Okay. So we're going to use our calculator just like we did in this previous problem, just to get practice with it. 1 prop z test. So 1 prop z test. And I'm going to write down what the calculator asked for. Sorry, guys. I'm getting a little bit of a cough or something. So we're going to go into stat tests. Number 5 on my calculator says 1 prop z test. Now, in this case, null hypothesis says that P is equal to 0.3. The X value is 50 failed, and there's 150 total. So we're going to do 0.30, comma, 50 fails out of 150, comma, this will be a greater than. Let me double check this. Okay, so this will be P naught is greater than. Okay, so now when I do this, I get my z-score is equal, my z-score is equal to 0.89. I guess if we want to, I guess it's 0.8909. And it also tells me the p-value, but I'm going to save that for step 5. So step 5. Step 5 says take our little drawing. And again, part of the reason you do the drawing is to kind of remind yourself what you're finding here. So we come over here and we have a right tail test. So we're going to shade this way and look on our calculator, and it says the p-value is 0.186. 0.186, okay? So that's what I get for my p, about 0.186499, but we'll go with 0.186. Now, again, I'm not going to double this because this is not a two-tailed test. This is exactly what we got. This is my p-value. You know what? Write it like this. Okay, so then we know in step 6, write 909. So here we go, part 6. Part 6 says, since our, and remember, 0.186, that is a pretty big p-value. That's almost 19% that the null hypothesis is true. okay? And our significance level was only 10%. So it says since our p-value is greater than our alpha equals to 0.10, we fail to, remember, when it's greater than, you fail to reject the null hypothesis, okay? So then we go to step 7, and we're kind of in the same boat as last time. We say there is insufficient evidence to support either claim, or to support rejecting the null hypothesis. Some teachers teach it that way as well. But if I can't reject the null, then I can't say it's true either. I just have to say, you know, I don't have enough evidence from this study, okay? Support either claim, okay? So that's kind of those two from okay, let's see. So that kind of covers the z-score ones. Let's move on to hypothesis test for means, okay? So this is a really good one. I, in the past, I've questioned very similar to this on your exam, so we actually will use this one. And again, for this one, I'll probably use, I'll do it by hand first, and then I'll show you that you could check it with the calculator just to make sure that you know how to do it. But this also has a calculator function on it as well, and I'll show you that down the road. So the main objective in this section is to develop the ability to test claims made about population means. So in the previous section, it was population proportions. The same requirements, the sample must be selected randomly, and either or both of these conditions are satisfied. The population is normally distributed, or the sample size is greater than 30, or both. You'll take either, okay? The distribution of the sample means follows a t-distribution with n-1 degrees of freedom. The steps are the same as for the previous sections. However, make sure to determine the test criteria using the t-values. So everything's the same. Nothing is going to change. We're going to do our 7 steps. We're going to build our claim. We're going to build our null. We're going to do everything exactly the same. The only difference is when we find our test statistic, our t, it will be done differently because t uses a different formula. So this is the formula we're going to use for anything with mean in general. Now, again, there is a rare exception to this, but in general, this is what you use when you're starting to talk about mean. So it says a past study claims that adults in America spend an average of 18 hours a week on leisure activities. A researcher wanted to test this claim. She took a random sample of 10 adults and asked them about the time they spend per week on leisure activities. Their response in hours are as follows, and then you guys can read that. So it says, assume that the time spent on leisure activities by all students are normally distributed. So bingo, we got our requirement. Use this sample information to whether the amount of time spent on leisure is different than what has been claimed at a 10% level, alpha level of 10%, or significance level of 10%. So here's the thing. Did they say that it's greater than or less than, or did they just say different? Okay, so when they just say different, then that means that you are dealing with a not equals to, okay? So I'm gonna, cross this out. Remember, I do it with 7 steps. Again, you guys can do it the way the notes have, because again, you're gonna be doing the test online for the most part. Because of our situation. So I can't force you, or I can't watch you do it or you won't be turning it into me. So you could do it with 5 steps like the calculator, like the book shows, but I'm going to show you the 7-step method anyway. So we're going to do step 1, claim, and opposite claim. Okay, so what's our claim? So our claim is that mu, let's see here. It says that a past study claims that adults in America spend an average of 18 hours per week. Okay, so that was a past study. Now, our new sample, so use the sample information to test whether the amount of time spent on leisure is different than it has been claimed. So mu is not equal to 18, And the opposite of that would be mu is equal to 18. Now, what if you did instead that mu equals 18 and is the claim, and mu not equals to 18 is the opposite? That doesn't matter so much. What really is important is that when you come over here to step 2 and you do the null, you have to get this right. So the thing you got to understand about step 1 is just about you writing it symbolically, okay? You're writing the words of the claim into a symbol for statistics, okay? So you're making parameters of mu equals 18 and mu not equal to 18. So now you're dealing with a statistics problem instead of just a word problem, okay? So it's very important you guys understand right here, we have just found a way to write all of the wording in this problem into these two claims. The mean is equal to 18 or the mean is not equal to 18. Now we have to make sure that whichever one has the equal sign is our null, okay? Let me make this a little bit better. Okay, so our null has to be mu equals 18, and mu then must be the other one. The alternate hypothesis must be the other one. So we now have the null and the alternate hypothesis, so I'm feeling pretty good. Now let's go to 3. We know the alpha level, or the significance level, is 0.0. Remember, this is our significance level. Okay, and that's what we're going to test the p-value against. So again, I'm going to do the p-value method, all right? So we now know that this is a two-tail test. So remember, if we didn't use the calculator, we have to, this means double the p-value at the end of step 5, okay? So you don't have to write all that. I was just saying, as a teacher, this is what I'm thinking in my head, is that I have to double my p-value because I forgot to do it last time, so I'm trying to remind myself. Okay, so we have step 1, we have our claim and our opposite claim. We now have built a null and a alternate hypothesis. We know that it's a two-tailed test. We know our significance level is 0.10 or our alpha level is 0.10. So now what we're going to do is we're going to calculate the test statistic. So for me, remember that this is my step 4, okay? In your book, it's step 2. So basically, to calculate the test statistic, I'm going to do t equals x bar minus mu divided by the standard error, which is the s divided by the square root of n. So there's a problem. I don't know x bar and I don't know s. However, they gave me data. So take out your calculator and enter this into your list. So once again, you put this into your list. So we're going to go into stat, edit, and then our list 1, we're going to enter all these numbers into 1. 14, 25, 22, 38, 16, 26, 19, 23, 41, and 33. Okay, so it should have 10 values, I believe. Yes. Now I'm going to go back into stat, going to go into calculate single variable stats. So you should have been doing this since probably chapter 3, I believe. Chapter 2 or 3 is when I taught you to do this. So you should know how to do this by now, okay? And it's very important. And it tells me that my x bar, is worth, on my calculator, 25.7. And it tells me that my standard deviation is equal to 9.04. I'll use 9.04, but it could be 9.04. Okay, so what I'm going to do now, you know what, I'll give it a 0.44. So what I'm going to do now is I'm going to do, did I say 25? 25.7 minus my mean. What's my mu? Well, remember, we got to go back and we look at the null hypothesis. The null hypothesis says that mu is worth 18. So I'm going to do 25.7 minus 18, and that's why the null has to be equals, because you're going to substitute this back in. And then our standard deviation is 9.044 divided by the square root of 10, because there were 10 10 adults in a sample, okay? So now we should get, let's do 25.7 minus 18 divided by parentheses 9.044 divided by the square root of 10, close parentheses. And I get about 2.69. So I'm going to say 2.69. It's about 2.692 if you want. That's okay. Okay, so we now have our test statistic. So this is the actual math that we were doing where we were working with the sample and the original claim of mu equals to 18, where we're comparing the two, okay? And then we're bringing into it the standard error of S divided by the square root of N, all right? So now we're gonna calculate our p-value, okay? So we could use the calculator, but you know, to just do a t test statistic, but I'm going to draw the picture. So this is, now remember, this is my step 5. Okay, oops, we're using black on this one. So this is my step 5, okay? And I'm going to draw the picture. Remember, the distribution's a little more subtle, okay? So now, and again, it's supposed to be symmetric. Now 2.692, that's going to be way over here somewhere, 2.692. And then this is my shaded region. But that also means there's a negative 2.92 over here. And this is my shaded region. So because this is a two-tailed test, I'm going to use both of these areas and add them up to be my p-value because it's a two-tailed test. So I'm going to do second vars, and I'm going to do TCDF on my calculator. So I'm going to do TCDF on my calculator. And it's going to go negative 99999, comma, negative 2.692, comma, degrees of freedom, 9. Okay. 2.692, degrees of freedom, 9. And I get this equals 0.012, okay? However, 0.012 is only half of the area, that's this guy. So then I also have 0.012 here. So I'm gonna multiply this by 2, and that will give me my p-value. So I'm gonna do 0.012, oops, 0.012 times 2, and that'll give me 0.024. Okay, I think I need to make my green a little bit softer. There we go. Okay, so we have a p-value of 0.024. If you use the calculator feature to find this all from scratch, I think it gets 0.025, but it should be okay either way. Okay, so we now have our p-value. Okay, now we're going to do step 6. We have to make our decision. Now it says make and justify a statistical decision. Now our p-value is 0.024, okay, and our significance level is 0.10, okay, or 0.10. So in this case, since our p-value 0.024 is less than or equal to alpha, which is, this is less than or equal to 0.10, which is our alpha, we reject the null accept alternate okay. So we did all of this work. We did all of this work and we justified it by telling somebody our p-value of 0.024 is less than our alpha of 0.10. You know what? I'm going to write it just like this. It just looks funny to me how I have it. our 0.024, p-value 0.024 is less than 0.01, which is our alpha, okay? So therefore, because we have a less than or equal to this time, we are now going to reject the null and accept the alternate, okay? So that means in step 5, but my version is step 7, we would say there is sufficient evidence to support the claim that, and then we have to go tie it into the problem, okay? So it says, assume that time spent on leisure activities by all adults are normally distributed. Use this sample information to test whether the amount of time spent on leisure is different than what has been previously claimed or recorded. So our alternative hypothesis says not equal to. So we're gonna say, does it seem like based on our information that it is in fact different than 18? It does, because we're accepting the alternate hypothesis. Remember, this is what we're accepting. We're accepting that it is not equal to 18. So there is sufficient evidence to support the claim that the mean amount of leisure, how do you spell leisure? Let's see. EI. No, I always spell it backwards. EI, leisure time, is different than 18. I think it's 18 hours per week or something like that. Okay, is everybody okay with that? So this is how you can do it. You know, by hand, you're going from scratch, you're doing everything. Now, I just want to show you that if you wanted to do this on the calculator, we could do this right here, but that would give us our test statistic, and it would also give us our p-value. So we could use this to check our work. So let's go stat test, and let's go to t-test. I think mine's way at the bottom. Oh no, it's actually the second one. So it says, do you want to use data or do you want to use the stats? Okay. So, in this case, we could actually use either because we know the data and we also know the stats. If you click data, that means that it's going to use the values that we inputted into list 1. So if you're using a list, this actually makes it really easy. If you aren't using a list and they provide you with the mean and the standard deviation, if you plug it in your calculator, it should already be there. So I'm just going to use stats because that's what we use to calculate it. And then we are dealing with a not equal to. So we would just go we would go t-test, and then we would do in this case 18. So they ask us for the mu naught, which is the null hypothesis, is 18. Then it asks us for x bar, which is 25.7. Then it asks us for the standard deviation, which is 9.04. And again, you guys should see all of this on your calculator, okay? And then it asks us for n, and that's equal to 10, okay? Oh, and then it asks us for not equal to, okay? So when I hit enter on all of these, it gives me a t-score of 2.69. Let's compare that. We got 2.692, so that's pretty good. It's actually 2.692 as well. We also got a p-value equals 0.0246, so about 0.025 if we round it off, 0.025, which in either case we would be okay. So here's the thing. Notice this answer and this answer are the same as what we got here and what we got here. So you guys can use this technique as well. I just like to show you how to do it by hand so you don't feel like you're just hitting enter on the calculator and you have no idea what you're doing, you're just hitting enter. But in reality, you could definitely use this to make sure that you got the correct p-value and you got the correct t-score. Now here's the thing. Notice that the calculator told me the p-value without having to double it. That's because you told the calculator that it was a two-tailed test. So it already knew to give you the p-value doubled. So it gave you the correct answer right out the gate. So that's why it's kind of nice to deal with problems like this on the calculator because they kind of give it to you ready to go. Okay. So I think the next one is, let's do this. So the next problem, I don't believe I like doing that one. Let's go on to this next one. Oh yeah, it's another big sample problem. So it says psychology experiment. Let me minimize this just a little. I do actually like this one. I have a few others that maybe I'll do in practice. They're homework problems that you guys have. Maybe I'll do that in the next meeting. But I do like this one. So let's give this one a shot. So something just to keep in mind also, by the way, this is a lot of numbers, but they already tell us X bar and the standard deviation. So we don't really have to plug this in, even though it looks like we're going to. We don't really have to. So once again, this is my, they do their step one is my version of step 1, 2, and 3. So let's do step 1. My step 1 is my claim. And again, you guys, I cannot emphasize enough how important it is to kind of get used to doing this. Otherwise, it's really going to feel like, you know, what am I even writing down? You really want to decide what's the problem saying for the claim, what's the problem saying for the opposite. Then once you're done with that, decide what your null is. Then once you're done with that, decide what type of tail test it's going to be, and it starts becoming kind of commonplace for you, okay? So are they talking about proportions, means, or are they talking about standard deviation? So it says psychology experiments sometimes involve testing the ability of rats to navigate mazes. The mazes are classified according to difficulty, as measured by the mean length of time it takes rats to find food at the end. So the mean length of time. So boom, I already know this is probably a mu problem, so I'm going to write down mu, okay? And it says one researcher needs a maze that will take rats an average of about 45 seconds to solve. He tests one maze at random on a random sample of 20 rats, collecting the below data, okay? So what is the time we're dealing with here? We're dealing with 45 seconds. He needs it to be about 45 seconds. So the mean amount of time the maze, let's read it again. One researcher needs the maze that will take rats an average of about 45 seconds to solve, okay? So this is going to be, I'm gonna say 45 seconds to solve or longer. One researcher needs the maze that will take the rats. Do a hypothesis will take, oh yeah, oh, I'm sorry. Right here, will take longer than the claimed researcher. Okay, so do a hypothesis test that tests rats will take longer than claimed by the researcher at an alpha level. So I didn't read this last sentence here, so this is important, okay? So it says, do a hypothesis test that the rats will take longer than claimed, okay? So he wants it to be 45 seconds, okay? So point, let's do this. Let's do longer than claimed, okay? So greater than 0.45. Oops. So greater than 45 seconds. Okay, so now think about this. We'll test that takes longer than what the researcher said. So we're going to go longer than 45. That doesn't mean equal to 45, right? So then the opposite of greater than 45 would be less than or equal to 45 seconds, okay? So now we got to build our null. So our H naught and our H alternate. Sorry about that, you guys. I stumbled over that a little bit. I was just trying to explain to you guys why I use greater than and less than or equal to. Now, remember, there always has to be everything covered. So we did greater than 45, so that means the extra had to be the less than or equal to 45. Every number has to be accounted for, okay, in the claim and the opposite claim. So now we have the null has to be the one that had the equal sign. Well, that is this guy. He had the equal sign. So the null is mu equals 45, and the alternate would be mu is greater than 45, okay? Now we know step 3 is the easy step. The alpha level is 0.01, and we know it is a right tail test. How do we know that? The alternate hypothesis has a greater than, okay? So we know it's right, okay? So it says calculate the test statistic, okay? So calculate the test statistic. So that would be my step 4, okay? So calculate the test statistic. So I'm gonna practice using the calculator now because they gave me the X bar and they gave me the S. So I could do it by hand, but we did the previous one already by hand up here, right? I did this one using the formula. So now I'm just gonna say, you know what, let me kind of go for speed and efficiency. Let's use the calculator. We're gonna do T test, and let's plug in what the calculator says. So we're gonna go stat test, T test is number 2 on mine. We're gonna use statistics. So in this case, what's our mu null? Our mu null hypothesis is 45. And it says that our X bar, they tell us the mean is 50.13 from the sample. They tell us the standard deviation is 9.90 from the sample. And how many rats was it? I believe it was 20. Yeah, it was a sample of 20. So we're gonna take 20 rats, and then we are doing a greater than. Okay, so let's calculate that. Now it gives me a t-score of 2 points. So oops, you know what? I didn't plug it in. I didn't plug it in as I was typing it. Let me help you guys out. So I was supposed to do 45, comma, X bar, which is 50.13, comma, 9.9, comma, 20, comma, greater than. And this is the mu naught. This is X bar. This is the standard deviation of the sample. This is the sample size, and this is the tail. Okay, so that's everything you just plugged into the calculator. And it's depending on which calculator you have. If you have the 84 plus, I believe it comes like ready to go. If you have the 83 plus, I believe you're gonna have to use commas for all that, but I would definitely look up the 83 plus on YouTube. I don't have that one exactly in front of me. So this one gives me my Z equals, gives me 2.317. So 2.317. I think I'm going to start using 3 decimal places when I use the calculator for Z's, even though the book only uses 2. It just seems to work better. Now let's see here. We got 2.317. Now technically, if you look on your calculator, you already see that you have a p-value of 0.015899. But we'll get to that in a second. So in my step 5, we're going to draw a picture. Okay. And we're going to shade on the right-hand side. So we're going to put 2.317 right here, and we're going to shade this area to the right. Now we know that this is my p-value, and according to the calculator, it's 0.0159. Okay, and this is my p-value. Okay. And again, I got that from the calculator using the t-test. If you didn't do that, then you would have to do TCDF, and then you would do 2.317, comma, 9999999, comma, degrees of freedom of 19. And you should get something very similar to what I just did, okay? Well, you know what, I'll do it for you guys real quick just to verify that I'm not making stuff up. So let's do second bars TCDF. We're gonna go from 2.317 to 9999999, degrees of freedom 19. And I get 0.0159, so I get a little bit bigger. Oh no, I get the exact same one, 0.0159. Okay, so we get the same exact p-value, okay? This is using the t-test, this is using TCDF, okay? Both are acceptable, especially the online. Remember, if you were taking the exam in class, I would make you write out all 7 steps and ask you to do it by hand. So you kind of got lucky a little bit, but it also kind of hurts you a little bit because the when you do it so much on the calculator, it almost sometimes will feel like you're just hitting enter, okay, on your calculator, and you don't know what you're finding. That's again why I emphasize draw these pictures, you guys. It kind of helps you find your bearings and let you see that you're actually finding area, and that area is the p-value, and that p-value is the probability that the null hypothesis is true. Okay, So 0.0159 is not a super small p-value. So we have to compare it, and we can't automatically say reject the null. So we're going to say since, or you know what, let's do this. Let's show my p-value of 0.0159 is, what's our claim? 0.01 is greater than our alpha of 0.01. So this is my p-value, greater than my alpha, significance level. This means since my p-value is greater than my significance level, alpha, we fail to reject the null. Okay, so in this final step, so what this is saying is there, and again, we're going to kind of go back to our template, there is insufficient evidence to, you could say, now I'll try to do it like the homework might say, technically there's insufficient evidence to support either claim, but it's really there's insufficient evidence to support the claim that the amount of time it takes to find food, I guess, find food in the maze is longer than 45. Okay. Now, again, I probably would have just said there's insufficient evidence to support either claim because I can't reject the null, and that means I can't accept the alternate. So I can't really support anything. Okay. But I think sometimes in the homework, they might ask you to expand on that. So you can say there is insufficient evidence to support the claim that the mean amount of time it takes to find food in the maze is longer than 45 seconds. We can't say that's for sure. We can't support that. And remember, that was the alternate. The alternate says that it would take longer than 45, right? If you're looking at step 2, and we can't support that, okay? So just so you guys know, that would be how you could answer that. And this would be my step 7, right? So now here's the thing. This next one we don't have run into. This is that rare case. It says, what if the population standard deviation is known? So if the population standard deviation sigma is known, we calculate our test statistic with a z-score rather than a score using the formula. So normally they will they will say the sigma is equal to something. So they'll tell you red alert, you know sigma, but you're still trying to calculate mean. So this is the rare example that I gave you. It hardly ever happens. It's not really something that should happen very often, but you could use this z-test, and I'm probably not going to ask you any test questions on this. It's so rare that it actually would occur, okay? I think that's going to be the video for today. I believe that should get you guys started, and then we'll finish up on testing claims about standard deviation and variance. So everything will be the same once again. You know what, maybe we can do this one right now. This is actually one that I have in my separate notes from the homework, but we can use this one as well. So let me see here. Oh no, the homework one is slightly different. So I guess I'll go through and do this one. Let me take a look here. Yeah, I guess we can do one. So again, if you know how to do hypothesis testing for population proportion, then you know how to do hypothesis testing for means. And if you know how to do hypothesis testing for population proportion and for means, then you also should know how to do it for standard deviation. So this example says, consider a random sample of 30 pennies. The mean weight is 2.4991 grams and a standard deviation of 0.01648 grams. The US Mint requires that pennies be manufactured to have a mean weight of 2.5 grams and a standard deviation of 0.0230 grams. Based on this sample, is there evidence to suggest the standard deviation is less than what the U.S. Mint specifies? Use a significance level of 0.05 and assume the weights of pennies follow normal distribution. So boom, they gave us normal distribution. We go up here and it says selected randomly and normal distribution. We're good. This is a formula we have. Okay. So we can use the chi-squared CDF function, or you could also use the chart that I gave you as well. Either one would work. On our calculator, I do not believe there is a way we can do this one on our calculator. Yes, if you look way down here, it says there is no calculator function built in to do hypothesis tests for standard deviation or variance. So the one that says stat test chi-squared test does not test for standard deviation or variance. It's a test for something else. Okay. So we actually do have to do this one by hand. There is no choice in case. So let's do state the appropriate null hypothesis. So let's see here. I think for this one specifically, I really like to do the p-value method. Even if we were doing it in class, the p-value method for this one, I think I like better. So let's try to give this one a shot using the p-value method again. So once again, p-value. This over here, the alternate method. This is if we were doing the test in class, I would use this one more often. This one is the traditional. I believe this is kind of like the old school one. And then the p-value method, if everybody has their calculator, it makes it kind of a little bit easier. Maybe I'm wrong. That just seems like the case to me. A lot of old school professors, including myself, we seem to like the traditional method better. So that makes me think it was before a lot of calculators were around. So let's do this one with the p-value, since you guys all have your calculators and you're going to be taking the test online for our situation. So first thing we need to do is we need to do, get rid of this. I don't like that. Okay, and we're going to do it my way. We're going to do step one, claim, and the opposite claim. And again, this is about writing it in terms of the proper notation. So this is like a notation step. They said, suggest that the standard deviation is less than the US Mint. So remember, you guys are testing standard deviation and it's less. So I'm going to say sigma is less than what? Less than what is claimed by the US Mint, standard deviation of 0.0230. You guys, I'm just looking through the problem and I'm finding the pieces I need. Okay, they say that the standard deviation is 0.0230 grams. And that's what the US Mint requires its pennies to be manufactured as. So that's what we're going to use. And if that is less than, then that means the other standard deviation, the opposite claim, has to be everything else. 0.0230 greater than or equal to. Remember, one of them has to have an equal sign. Okay, so now step two. Step two says the null and the alternate hypothesis. By the way, you might also see it in some books like that, you guys, with a 1. So the first one is the null, H sub naught, and then H sub 1 means the other hypothesis. But I like to write what I mean, so I'm going to write the alternate hypothesis, okay? So we know the null is the one with the equal sign, so we're going to say the standard deviation is equal to 0.0230. And we're going to say the alternate hypothesis is the standard deviation is less than 0.0230. We're going to do our step 3. And I hope you guys are noticing there's a pattern here. Every single one of the problems in Chapter 8 has all been done the same way. Steps 1 through 7, you take your claim, you take the opposite, you identify the null, you find alpha, or you state your alpha, you decide two-tail test, one-tail test, left tail, right tail, so on and so on. You find your test statistic, you make a decision based on that, and then you make a conclusion, okay? So every single one of these problems should feel the same because they all are the same. You are doing a process. It's called hypothesis testing with statistics, okay? So now our alpha level is worth 0.05. And again, they will say in general, it will be given. And this is a left tail test. Because once again, I have my alternate hypothesis is a less than, so it's a left going facing left. So now we're going to calculate the test statistic, okay? So we're going to say chi-squared is equal to, and let's look at the formula they gave us. It says n minus 1 So this is consider a random sample of 30 pennies. So this means n minus 1 is 29. Our standard deviation is what of the sample? They say the mean weight is 2.4991 grams, and the standard deviation from the sample is 0.01648 squared. So you guys, just again, I got it from right here. They say the standard deviation from the sample is that. The mean weight from the sample is that. And now I have to divide this by the standard deviation squared. Well, I'm going to get that from the null. The null told me, so hopefully you guys are seeing me drawing this highlight right here. The null tells me that the standard deviation of the population is 0.0230. 0.0230. And then we square that as well. So let's see what we get on our calculator. So I'm going to do 29 times parentheses 0.01648 squared, close parentheses, divided by 0.0230 squared, and I get approximately 14.88, I guess 9 if you want. Okay, we could do 3. Okay, so this is my step 4. Okay, now let's do step 5. We're going to calculate my p-value. So now remember, this is a different drawing. This is one of these guys. This is the chi-squared distribution. Okay, and we got 0 is the starting point, and we have 14.889. It is a left tail test, so I'm going to say it's over here more than likely somewhere. I don't know exactly. Okay, and this will be 14.889. Okay, so I'm going to go on my calculator. You could also use your table, but I don't, well, I guess maybe I could find that, but we're going to do second vars, and we're going to go on our calculator until we find chi-squared CDF. On my calculator, it's number 8. So I'm going to do chi-squared CDF. Okay, I think this might be the first time we've used it for our class. I believe we used the table in chapter 7. So we now have chi-squared CDF. Let's see what they want. They want the lower bound. Well, that's going to be, it's technically 0, but go ahead and use -999. So I'm going to use -99999, but it's actually 0 because it can't go lower. The upper bound is 14.889, and the degrees of freedom is 29 because there were 30 pennies. So 14.889, degrees of freedom of 29. Hit enter, and I get approximately 0.014. Yeah, let's say 0.0141. So this is my p-value. So that means this area right here is 0.0141. Okay, so this area right there. All right. Let's see. Okay, so now my step 6, make and justify statistical. So I'm going to go a little bit quicker on this one. I'm going to just kind of, instead of being really wordy, I'm going to kind of get to the point. So again, you guys definitely remember you can use this instead of the table that I gave you. It's probably more accurate than the table. And we are now going to justify. So we're going to say my p-value and my alpha. We're going to compare them. So my p-value is 0.0141, and that is less than or equal to my alpha. My alpha was 0.05. Okay. So because my p-value was less than my alpha, we, since, you know what, I'll just cut to the chase. Reject null. Now, why are you able to reject the null and accept the alternate hypothesis? Because your p-value is less than or equal to your alpha, right? This means reject null. Okay, so now we have to do our conclusion, our step 7. We say there is sufficient evidence to support claim. And now what claim are we supporting? We're supporting the alternate hypothesis because we rejected the null, to claim that the population standard deviation or you could even say the true standard deviation, that the, I'll say true standard deviation, what is it, of pennies? Standard deviation of mean weight is less than 0.2030. I'm sorry, 0.0230, or that, oops, you could also say less than, or say less than what you specify. But what do they specify? That it's 0.0230, okay? So this is how you can do pretty much everything in chapter 8 now. I'll probably go over this one maybe in another video. We're going to do a confidence interval in another video, but you should be able to do almost everything from chapter 8 now. And in our next meeting, I'll probably do one of each. I'll do another T one, and I'll also do a chi-squared one also, okay? But this should definitely get you guys started. And I will see you in next class or talk to you for the next video. Take care, you guys. I'm going to end the recording now.